All right, today we're going to dive into a classic but super important engineering problem. How do you handle all that initial data your application needs just to get up and running? We're talking about doing it the right way, safely, professionally, and the key to all of this is something called an idempotent database seeder. So let me ask you this. Have you ever had one of those days? You push some code, the app restarts, and bam, it just crashes. Instantly. You scramble to check the logs, and yep, there it is, a database error. It is just so frustrating, and it happens way more than we'd like to admit, right? And you know what the crazy part is? The root cause is often this little startup script, one that's just trying to do something simple, like add a few default users or some basic settings. It worked like a charm the first time you ran it, but the second time, it tries to create the same data all over again, hits a duplicate key error, and the whole thing just blows up. Well, that exact problem is what we are going to solve today. Okay, so here's our game plan. First, we'll really nail down the startup data problem. Then we'll get into a great analogy, blueprint versus furniture, that'll make it all click. After that, we're going to pop the hood and see how this seeder actually works. We'll talk about the idempotency safety net, which is the secret sauce, and wrap up by seeing why this whole approach is just smarter by design. So let's get right to the heart of it. The real tension here is that, on one hand, your app needs some data to even function. But on the other hand, your startup process has to be tough enough to handle restarts over and over again without breaking. A script that only works once? Man, that's a ticking time bomb, especially in today's world of automated deployments. So how do we defuse that time bomb? Well, it all starts with a shift in how we think about this. The absolute key is to separate the structure of your database from the actual data that lives inside it. I love this analogy. Think about building a house. You've got the blueprint, which is the structure, and then you've got the furniture you put inside. And that distinction is just everything. On one side, you have your migrations. That's your blueprint. They're structural. They define your tables, your columns, all that stuff. And they're meant to be run just once and then versioned. But then you have your seeds. That's the furniture. It's all about the data that populates those tables. And these need to be totally rerunnable and what we call idempotent. If you mix these two up, you're going to pollute your migration history. And trust me, trying to do a rollback becomes an absolute nightmare. Okay, so that's the big idea. Blueprint versus furniture. Makes sense, right? But how do we actually put this principle into practice? Let's take a look under the hood at the mechanics of a really well-designed seeder. And you'll see it's actually beautiful in its simplicity. The secret sauce, the real magic here, is a simple, dedicated tracking table. Let's call it seed_history. You can think of this as the system's own little memory. Before it even thinks about running a data script, it just peeks into this table and asks, hey, have I done this one before? And that simple check builds into this really clean 6-step process. So for every single seed file, the system first checks that seed history table. Is the file name in there? If yes, great. It just skips it and moves on. If not, then it kicks things off. It starts a database transaction, runs the SQL to insert the data, and then, and this part is absolutely critical, it inserts the file name into the seed history table inside that very same transaction. Then, and only then, does it commit everything. It's an all-or-nothing deal. The data and the record of adding it are tied together forever. What this whole process does is build this incredibly powerful safety net, and it's all based on a really important computer science principle called idempotency. Honestly, this concept is what takes the system from just working to being truly professional grade and fail-safe. So I've used that word a few times, idempotency. What does it actually mean? Well, to put it simply, it's an operation you can run 1,000,000 times and you'll get the exact same result as if you just ran it once. Think of it like pressing the mute button on your TV remote. The first press mutes it. Pressing it 10 more times doesn't change anything. It stays muted. No errors, no duplicates, no weird side effects. Now, what's really cool about this design is that it gives you two completely independent layers of safety. It's like a belt and suspenders approach. First, at the application layer, you've got that seed history check we talked about. That stops the script from even trying to run a second time. But let's say, for some crazy reason, that failed. You've still got a second layer of defense right down in the database itself. The SQL is written with a clause like, on conflict, do nothing. It's literally telling the database, hey, if you see this data already exists, just, do nothing. Chill out. Move on. So when you put all these pieces together, the history table, the transactions, the two layers of safety, you get a system that's just fundamentally smarter. It's not just a script, it's a robust process.
And the payoff is huge. You get a seeder that's predictable, totally safe, and honestly, a real pleasure to work with. Let's just quickly run through how this behaves in the real world. So on the very first run, of course, it applies all the seed files just like you want. But on every run after that, it intelligently skips what's already been done. No crashes. In a test environment, the whole thing is skipped entirely, which is perfect for keeping your tests clean and predictable. And what if a seed file has bad SQL? The whole transaction gets rolled back, so you're never left with a half-broken data state, and the app just halts safely. It just works exactly the way you'd hope it would in every single case. And the wins just keep coming. There are a few other smart design choices here. We've already talked about transactional integrity, that all-or-nothing safety, but it also guarantees ordered execution. By just using simple number prefixes on the final names, 001 underscore, 002 underscore, it makes sure that 001 underscore always runs before 002 underscore. This is a lifesaver when you have data that depends on other data. And one last pro tip, it avoids a really common trap by referencing data using a stable, unique value, like a domain name, instead of a fragile, auto-incrementing ID that could be different from one database to the next. But maybe the biggest win of all is what this means for the development team day to day. This quote really nails it. Adding new seed data doesn't mean you have to go digging around in the application code. Nope. You just create a new, numbered SQL file, drop it in the folder, and that's it. The system handles the rest. It is so simple, so maintainable, and it scales beautifully. So, I want to leave you with this one final thought. We've been talking about data seeding, which is a perfect example of this. But this powerful idea of idempotency, it's useful everywhere. Think about your API endpoints, your message queue handlers. Take a look at your own system. Where else could building in this kind of safe, repeatable operation save you from a crisis down the road?